So my name is Asmi, as Rob mentioned, and I'll be presenting the Ferrofluid Pump, which, as you can see here, is an electromagnetically powered pump. And the idea was to have something with no rigid parts made from ferrofluid, which, if you don't know, is a magnetic fluid. And I'm working with Asmi, who's actually in the call right now, and Sid, who can make it, and with a lot of help from Robert. Now, like we said, initially it was a little bit slower. So initially we just started with a ferrofluid plug, and we tried to understand how much pressure could it hold and how could we change like the amount of turns, the core material and the core shape, and how many things we can change to really get a strong pump or a strong plug. And we learned that the horseshoe configuration was a bit stronger, using thicker wire and a soft iron ring as a core. Kind of like those kind of initial conclusions were made to now lay the foundation of what we're working on right now. And now with that kind of foundational knowledge, we're designing a pump that works by pulling ferrofluid up by turning on and off this magnet that you'll see.
So Robert L. Reed on December 17th, testing out for the first time the boat pump concept using ferrofluid and a 2-amp power supply.
And as you can see, it can be a little bit hard to see because ferrofluid is so dark and almost impossible to look at, really. But it is
pretty well.
It is pumping quite, like like you said, it's pumping quite well. And now after automating that pumping, we got a little bit of a more obvious and more efficient
pump with no moving parts test with 30 millisecond pull and 40 millisecond let.
And now, as our future steps, we kind of saw this initial success, and we want to start making a setup with multiple magnets, as you can see here on the right side. And these will be coiled. They're not coiled yet, but they will be coiled. And with more magnets, we'll get a stronger pump, hopefully. And that includes making a transistor setup, as you can see on the left, which is just a short video of like proving that it works. I don't know if you can press the left video or.
This is the current 4-transistor design without code. So it's just the buttons are directly driving the 4 transistors. As you can see, they do all work, and it takes amperage from the power source rather than the Arduino. Arduino serves as a voltage supply to drive the transistor gates.
Oh yeah, so like we're basically working on how to make this singular magnet pump boat into something that requires more or can use more magnets to pump at a stronger rate and a stronger pressure, hold a stronger pressure. And we're going to also consider, using air pressure. So now it's not something that has to be vertical. It's kind of a lot of future things to do, and it is really exciting. And that's about it. And thank you, Rob, and thank you, Public Invention.
Thank you. So we actually don't have any awards to give this team. A lot of this success actually came in 2026. But I do want to add one thing. I shouldn't jump in here, but I want to emphasize something because it just can't be said enough. What you just saw was not a very good pump, right? It only pumped a little bit of fluid. It has no moving parts. No moving parts. Get that? We're pumping fluid with no moving parts. This is approximately the first time this has ever been done. This is really, in my opinion, kind of a big deal. This is a game changer, because if you can make a pump that has no moving parts, you can make an extremely small version of it. For example, to move a fluid over, for example, a very hot microchip, or for other biological purposes. So it looks like a janky little toy, but this is actually a very interesting invention, in my opinion.